Assalamu alaikum, good morning. I take this opportunity to thank you, Qatar Society for Engineers, for organizing this green technology, green engineering conference and exhibition. So today I'll talk about green engineering, its principles and applications in modern society. So I'll talk about what is green engineering and its principle, then how to sustainably design aspects of waste management, and the applications of green engineering in industrial operations, and what NASA is doing on green engineering, and academic program around the globe on green engineering, and then I'll conclude. So green engineering, what it is? Green engineering is the design, commercialization and use of processes and products in a way that reduces pollution, promotes sustainability and minimizes risk to human health and the environment without sacrificing the economics, viability and the efficiency. Green engineering embraces the concept that decisions to protect human health and the environment can have the greatest impact and the cost effectiveness when applied early in the design and development phase of a process or product. What are the characteristics of green engineering? So historically, use system analysis and integrate environmental impact assessment, conserve and improve natural ecosystem while protecting human health and well-being, use life cycle thinking in all engineering activities, ensure that all materials and energy inputs and outputs are inherently safe and benign as possible, minimize depletion of natural resources and strive to prevent waste. Additionally, green engineering develops and applies engineering solution while being cognizant of local geography, aspirations and cultures. It creates engineering solutions beyond current or dominant technologies and innovating and invents new technology to achieve sustainability. Actively engage communities and stakeholders in the development of engineering solution. And I think this is a platform that we are doing the third one. So there are 12 principles for green engineering. It should be inherent rather than circumstantial, prevention rather than treatment. So in the design stage, include strategies so that you are not required for the treatment. You can prevent it before it happens. Design for separation and purification operations should be designed to minimize energy consumption and material use, maximize the efficiency. Products and processes and systems should be designed to maximize mass, energy, space and time efficiency. And output pull rather than input boost. Conserve complexity, durability rather than immortality, meet need, minimize excess. Minimize material diversity and integrate materials and energy flow in terms of heat integration or energy integration, design for commercial afterlife and renewable rather than depleting. Now, if you want to see what is happening for waste management, so if you can identify the system boundaries and also put what are the inputs and output, so we can see that the input in the system now in the input we have the raw materials and the energy as the input, and in terms of output we have different products. We have the water effluents, atmospheric emissions, solid and hazardous waste, heat, radiation and other releases. And the raw material coming into the plant, and then we have the raw material extraction, and then within the plant we have the transportation and then manufacturing. So after the manufacturing we have use the product, sometimes we reuse it and maintain it, and then we recycle it after the use and do the waste management. And in terms of energy efficiency, so we need to develop a system in such a way to maximize the efficiency. And now if we focus on the energy and mass balance, so for overall system, so the amount of energy and mass coming into the system and going out, so we need to be careful about that as well. Okay. Now for the previous, please. Okay, thank you. So now for the life cycle assessment analysis, so we can see that first we need to set up a goal, and then we need to do the inventory analysis. So identify and quantify what are the energy, water and materials uses and environmental releases as well. And then after that we will do the impact analysis. So after the impact analysis, we will interpret the inventory analysis and impact analysis data in order to take a better decision for our product, processes and service with a clear understanding of what we want to do and what are the uncertainties available and assumption uses to generate the results. Okay, now if we want to see that what are the life cycles product different point of exposure and the risk available for the useful life of the product. So the occupational exposure can be there, and then consumer exposure can be there. So the raw material coming into the plant, and then the product is getting manufactured, and then the consumer use the product, and after the use it can be recycled or it can be incinerated or landfills, or and then there will be industrial releases or the releases in the landfill and incarnation. So from there the human and ecological exposures will be there. So these are the total life cycles analysis for a particular product. So we need to understand what are there, what are the different points of exposure, what kind of risk are there, and we will take proper action for that. Now how we make a decision? So we'll first ask a question for risk management need identified. After that we will ask a questions, are alternative available for that particular product or technology? If no, then the best practice to decrease worker and community exposure, probably it will take more than 1 year. And if the alternative available, so the next question we will ask, use life cycle thinking to understand major impact of the product and alternatives. From there we will where in life cycle are environmental and human health impacts. If it is throughout the life cycle, then alternative analysis, life cycle assessment, conduct life cycle assessment to identify better alternatives or otherwise improve risk management. So it will take probably 2 years. And if the critical exposures at use and end of the phases, not continuous, then we will ask this question, can safer alternative be identified? If no, then alternative analysis, chemical hazard assessment, etc. will do, environmental and human health analysis. It will take probably 1 to 2 years. And if the safer alternative can be identified, then we'll put safer product leveling, and then we can put some incentives and some logo, and it can take probably up to 6 months. Now we'll see some of the examples of application of green energy initiative in industrial operations. So for example, for the production of methyl acetate from methanol and acetic acid, so the traditional distillation reaction and distillation process was there. Now instead of traditional reactor and distillation process, if we can employ reactive distillation. So it will have benefits such as improve the selectivity, so reduce the raw material uses, reduce byproduct, prevent pollution and reduce energy uses, handle difficult separations, avoid separating reactants, eliminate or reduce solvents, enhance overall rate and beat the low equilibrium constraint. So in terms of diagram, so in the left hand side, so that was the traditional design using reactor and distillation and the right hand side is using the green engineering, which is in place of reaction and distillation, just use reactive distillation process. Now we can take another example of reducing automobile emissions and saving energy. So there has been a case study in the US. So based on ultralight steel auto body advanced vehicle concept. So instead of using normal commercial grade steel for the automobile industry, so for the targeted mid-size sedan, if we use ultralight steel, and we can see the data in the table below. So the standard the US mile per gallon for the standard one is 27.5, and using this lightweight steel concept, the mileage can be increased to 52 for gasoline and 68 mile per gallon for diesel, and carbon dioxide emission also can be reduced from the benchmark of 204 to 108 for gasoline and 92 for the diesel. And we can take another example in paper industry. So to eliminate the use and exposure of hazardous chemicals in the bleaching process, a new delignification agent, a polyoxymetallate (POM) can be used, and the technology eliminates the use of hazardous chemicals while maintaining effective lignin removal. So these are the two processes, and the advantage we can see in the next slide. So if we use the POM, which is the in a greener way, so we are basically not using sodium hydroxide, sulfuric acid, the chlorate, etc. So the issue is that if we use the POM, so the advantage is that we are no longer using the hazardous chemicals. However, we will be using more electricity and more steam. That means we need to put more cost for the operation, and we need more capital expenditure as well. So there will be a trade off between the advantage and the challenges, and we need to take a decision what to do about that. So for this particular issue, we need to do more research on the availability of other chemicals instead of the hazardous hydroxide, acid, etc. Now the third example is the minimizing worker exposure to mist in the auto industry. So in this case, the exposure to mist from machining fluid can cause serious health problems, including cancer, respiratory problem, etc. A cost effective method is to reducing the mist from oil based liquids has already been widely used. So for straight oil fluid, polyisobutylene can be added to control the mist. In addition of 70 parts per million PIBs, so they can increase this. So the issue is that this additive has been used extensively in the auto manufacturing processes, and the cost is quite low. And in this slide, we can see that after using the chemicals, the polyethylene oxide, the high treatment levels are needed, and 70 ppm of PIB added, and 40% reduction in average mist level, 67% reduction in the peak level, and 24 hours plus service life. Now let us take what NASA is doing, because they are very huge organization, and they are very famous for the space exploration since 1960s. So NASA has been working on putting green engineering issues to enhance their sustainability efforts, because if we see that different countries in the world, they are putting legislation so that you can operate some of the technology. There will be issues on use of chemicals. So based on the regulations of different countries, so you need to be very careful about doing that. So to accomplish its mission by minimizing and mitigating risk, especially those from the materials that are obsolete or restricted by national or international environmental regulations. So, to enhance effective and efficiency by increasing different stage. So, NASA and their technology evaluation for environmental risk mitigation principle center. So, they have a center for that. So, they work collaboratively with different agencies like the Department of Defense, US Air Force, etc. And they also tested lead-free electronics assemblies in space, and it could be used on low Earth orbit space. And NASA is also developing green propellant, which is alternative of hydrogen. So, what is their approach? So, their approach is to improve the decision making process, influencing procurement processes, inspiring and motivating and incentivizing designer, engineers and managers, and communicating and educating students and the engineers who are working, and collaborating with different stakeholders, reducing the use of energy, water and other resources, and increasing the applicability of energy and other exploration technique used available in the earth. So, these are some of the pictures. So, the photograph in the right hand lower corner is basically is a space station, International Space Station, where NASA tested lead-free electronics devices, and it is operating nicely. Now, what NASA is doing on green engineering? So, they have developed a 3-day green engineering courses. Okay. So, the objective of those courses is basically the identifying and communicating NASA engineering challenges and opportunities regarding environmental impacts and future risk and potential solution, designing and developing materials, product, processes, hardware and system that are inherently safe, generate less waste and use energy more efficiently, and describing and applying basic life cycle assessment techniques for engineering new product, considering environmental and energy impacts throughout the life cycle of the project. So, probably we can learn from NASA, and probably Qatar Society for Engineers can think about developing a course for green engineering, and then Qatar University, Hamad bin Khalifa University and Texas A&M can be a partner in that, and it will help the engineers and people working in the industrial sector of Qatar to understand what is green engineering and how they can apply in their work life. And the various academic program, there are an undergrad program in Virginia Tech and Texas, University of Texas and Austin, and graduate program in University of Pittsburgh, University of Michigan, and Yale University, Carnegie Mellon University, and both undergrad and postgrad on green engineering in Arizona State University. So, to conclude, we can see that green engineering is basically the way we do our business, and now focusing on use of less energy and less oil and less resources, and we can see that we can incorporate the green energy stuff from the design processes, etc. And opportunities for engineers to enhance their learning and green engineering. Now, I am from the chemical engineering department in Qatar University. So, some of our courses is already having some of the green engineering aspects, and we have some special courses like heat integration and pollution control. So, those are basically green engineering courses, and then in the final year all the chemical engineering students do a design project. And that is basically 6 credit course or equivalent to 2 courses. So, in that course what the student do is basically they design a product. So, they build a plan. So, they do all the calculations for a plan, and their focus is to basically minimize the energy uses, minimize the water uses. Okay. So, the chemical engineering graduate from Qatar University, they have in their curriculum some of the green energy applications. Thank you very much for your attention. So, if you have any question.